forget Mars. What if I told you there's a place in our solar system where you could walk outside without a spacesuit? Well, sort of. You'd be floating 50 kilometers above the most hellish surface in our neighborhood, in a city suspended by balloons, breathing air while sulfuric acid rains down from above. Welcome to humanity's future on Venus. But what would it take to build a civilization in the clouds of hell itself? And could Venus actually be a better choice than the red planet everyone's obsessed with? Venus is Earth's evil twin. It's almost the same size, almost the same mass, and it's our closest planetary neighbor. But that's where the similarities end. The surface of Venus is a nightmarescape that makes Mars look like a tropical paradise. We're talking about temperatures hot enough to melt lead, around 465 degrees Celsius. The atmospheric pressure at the surface, 92 times that of Earth. That's the equivalent of being 900 meters underwater. And just to make things extra fun, clouds of sulfuric acid circle the planet and it rains metal. Yes, metal rain. For decades, we've been dreaming about Mars. Elon Musk wants to die there. NASA's got rovers rolling around up there right now. But here's the twist. At 50 to 60 kilometers above Venus's surface, the conditions are shockingly Earth-like. The temperature sits around 20 to 30 degrees Celsius. The atmospheric pressure is similar to Earth's. And here's the kicker. On Venus, normal air is a lifting gas. A habitat filled with the air we breathe would float like a balloon in Venus's thick atmosphere. So what would colonizing Venus actually look like? Picture this. Massive floating cities, kilometers wide, suspended in the Venusian atmosphere like jellyfish in an alien ocean. These aren't flimsy balloons. We're talking about robust, multi-layered structures made from advanced materials like graphene and Kevlar, capable of housing thousands of people. The habitats would be filled with breathable air, a mixture of nitrogen and oxygen, just like on Earth. On Venus, this air is actually lighter than the carbon dioxide atmosphere, so your entire city becomes a giant airship. No complex buoyancy systems needed. You'd live in rotating cylindrical sections that create artificial gravity through centrifugal force, or in zero-gravity zones where you could literally fly through your apartment. The first colony ship arrives after a 4-month journey from Earth. A fleet of autonomous drones deploys from orbit, carrying the collapsed habitat structures. As they descend through the sulfuric acid clouds, protective shields vaporize the droplets. At 55 kilometers altitude, the drones activate the inflation sequence. Within days, the first habitable bubble expands in the Venusian sky. But let's talk about the elephant in the room. You're living in a cloud of sulfuric acid. How do you not, dissolve? The habitat exteriors would be coated with Teflon-like materials that acid simply can't touch. Think of it like a raincoat, but for an entire city. Multiple layers of protection would ensure that even if one layer fails, you've got backups. And here's something wild. You could actually step outside, not onto solid ground, obviously, but you could walk out onto external platforms with just an oxygen mask and acid-resistant suit. No bulky pressure suit like on Mars. You could fly between structures using personal propulsion units. Imagine commuting to work by jetpack through golden clouds while the sun sets over an endless amber sky. The day-night cycle on Venus is bizarre. One Venusian day lasts 243 Earth days. But at the altitude where the colonies float, super rotating winds whip around the planet at 100 meters per second, circling Venus every 4 Earth days. Your floating city would drift with these winds, experiencing a more reasonable day-night cycle as you orbit the planet. Now, you might be thinking, great, we're floating in the sky. How do we get resources? Here's where Venus becomes surprisingly brilliant. The atmosphere is 96% carbon dioxide. That's a gold mine. Using atmospheric processors powered by solar energy, you could extract carbon and oxygen. The carbon becomes building materials, graphene for structures, or even fuel. The oxygen becomes breathable air. Venus receives about twice twice the solar energy that Earth does, and way more than Mars. Your floating city would be wrapped in solar panels, soaking up endless energy. With abundant power and raw materials literally in the air around you, you could manufacture almost anything. 3D printers would churn out tools, spare parts, even new habitat sections. Water would come from multiple sources. Venus's atmosphere contains traces of water vapor and sulfuric acid, which is H2SO4. Through chemical processing, you extract the hydrogen and combine it with oxygen from CO2. Comets could be captured and mined in orbit. With the water sent down to the cloud cities, every drop would be precious, recycled endlessly through advanced closed-loop systems. But what about the heavy stuff? Metals, rare elements, minerals. Venus's surface is rich with them, but accessing that hellscape would require some serious engineering. Autonomous mining drones, built to withstand the pressure and heat, would descend from the floating cities. These aren't your typical drones. Picture something more like a small submarine designed for lava instead of water. These drones would land, scoop up regolith and minerals, and launch packages back up to the habitable zone using small rockets or even railgun systems. The extreme surface conditions would destroy most equipment quickly, so these would essentially be kamikaze missions. But Venus's thick atmosphere is perfect for aerobraking, making launches and landings more fuel efficient than on Mars or the Moon. Some visionaries propose an even more ambitious idea: cooling zones on the surface by deploying massive shade structures or using chemical processes to temporarily reduce local temperatures and pressures. Imagine carving out small pockets of survivable conditions for more extensive mining operations. What would life actually be like in a Venusian cloud city? Your home might be in a rotating ring section where down is always toward the outer wall. You'd have wide open spaces with parks, trees grown under grow lights, and artificial streams. But venture to the zero-G core and suddenly you're in a three-dimensional city where buildings extend in every direction and people sail through the air. Schools would teach students to navigate in 3 dimensions. Sports would be completely reimagined. Imagine basketball where you can fly, or swimming pools where water forms floating spheres. The younger generation born on Venus would develop differently. Their bodies adapted to the constant motion and variable gravity. Food production would happen in vast hydroponic farms, massive chambers filled with crops growing under LED lights, powered by Venus's abundant solar energy. Algae tanks would produce protein, and eventually lab-grown meat might supplement diets. The cuisine would be unique, Venusian fusion, combining Earth recipes with ingredients that can only be grown in the colony's specific conditions. So why Venus instead of Mars? On Mars, you're stuck in underground bunkers or surface habs, constantly fighting radiation and dust storms. The thin atmosphere provides almost no protection. Every time you step outside, you need a full pressure suit. Growing food requires heated, pressurized greenhouses. On Venus, you're protected by 20 kilometers of thick atmosphere above you, shielding you from cosmic radiation far better than anything on Mars. The gravity is nearly identical to Earth's, 90%, compared to Mars's 38%. That means your bones and muscles won't waste away. Children could grow up with bodies similar to Earth humans, not the elongated, fragile physiques that Mars colonists might develop. The counter-argument? Mars has solid ground. You can land, build, and mine without floating in the sky. Mars has water ice at the poles and possibly underground. The surface is harsh, but it's accessible. Venus's surface, by contrast, is basically inaccessible with current technology. But here's the thing, we're not colonizing planets for the surface, we're colonizing them for the resources and living space. And Venus's habitable zone is enormous. You could fit thousands of floating cities in the Venusian atmosphere, each one a self-contained nation. Mars's surface might be bigger on paper, but how much of it is actually usable? Of course, things wouldn't be all smooth sailing. Imagine this scenario. A massive solar storm disrupts the colony's electrical systems. Solar panels get fried, power drops to emergency levels, life support starts failing. The acid-resistant coating on one sector of the habitat begins to degrade without the active electrical defense system. A frantic repair operation begins. Engineers in acid suits rappel down the exterior of the habitat while suspended in Venusian clouds, racing against time to patch the damage. Inside, colonists huddle in central safe zones. The air grows stale, temperature regulation fails, and it starts getting uncomfortably warm. Then someone remembers the backup batteries. They were designed for exactly this scenario. The colony runs on backup power for 3 days while repairs continue around the clock. Drones salvage solar panels from a decommissioned observation platform nearby. Slowly, power comes back online. It's a sobering reminder: on Venus, there's no room for error, but the colonists adapt, learn, and implement better systems. Here's something absolutely mind-blowing. Some scientists think Venus might have been habitable in the past. About 700 million years ago, before massive volcanic activity resurfaced the entire planet, Venus could have had liquid water oceans for up to 2 billion years. That's longer than Earth was habitable before complex life emerged. Some speculate that Venus might have even had life before it turned into hell. If that's true, we wouldn't just be colonizing Venus, we'd be reclaiming it. Maybe buried beneath those crushing volcanic plains are fossils of organisms that thrived when Venus was a water world. Finding them would be the greatest scientific discovery in human history. And maybe, just maybe, our floating cities would be the first step toward terraforming Venus back into the blue planet it once was. So, what if we colonized Venus first instead of Mars? We'd be living in floating sky cities, mining the clouds for resources, and thriving in one of the most extreme environments in the solar system. We'd develop technologies that could revolutionize not just space exploration, but life on Earth. Advanced materials science, closed-loop life support systems, atmospheric processing. These innovations would filter back home. Venus would force us to think differently about colonization. We wouldn't be conquering land, we'd be mastering the air. We'd become builders of cloud kingdoms, engineers of floating civilizations. And who knows, those cloud cities might just become the template for colonizing the gas giants' atmospheres, or even free-floating habitats in deep space. Mars might be the trendy choice, the one everyone's talking about. But Venus is the dark horse, the underdog, the planet that's been written off as impossible. And if humanity has proven anything, it's that we love proving the impossible wrong. So maybe it's time we looked up at that bright morning star and saw it not as Earth's evil twin, but as our future home in the clouds. The question isn't if we can colonize Venus. The question is, are we bold enough to try